So today I'll be doing chapter 19, number 59 in our physics notebook. It states you come into a lab one day and you find a well-insulated 2000 milliliter thermos bottle containing 500 milliliters of boiling liquid nitrogen. The remainder of the thermos has nitrogen gas at a pressure of 1 atmosphere. The gas and the liquid are in thermal equilibrium. While waiting for the lab to start, you notice a piece of iron on the table with 197 grams written on it. Just for fun, you drop it. You drop the iron into the thermos and seal the cap tightly so that no gas can escape. After a few seconds have passed, what is the pressure inside the thermos? The density of liquid nitrogen is 810 kilograms over meters cubed. So I just highlighted what's going to be important. And then I just drew out the thermos bottle, which is going to be 500 milliliters of liquid nitrogen, and then the rest is going to be gas. And then I also wrote things that are going to be important that they don't give to us, but you could easily find in your book. And that's going to be the temperature in which liquid nitrogen boils, the room temperature, the specific heat of iron, the nitrogen heat of transformation, and the volume of nitrogen gas. So first things first is we're going to find the heat energy transfer of change in temperature of iron. So that's going to be given by Q equals MC in the change of temperature. Then the mass is 0.197 kilograms. The specific heat capacity of iron is 460.5. And then the change in temperature is going to be the change in room temperature and the temperature in the container, which is going to be equal to the boiling nitrogen. So here you get 2.0 times 10 to the 4 joules. And then we have to find the total mass of nitrogen that is vaporized. So this is just important. You have to keep in mind that the liquid nitrogen is still boiling. So you still have liquid that's transforming into a gas. So to calculate the pressure, you need the total volume of the gas and the total moles of the gas. And in order to do that, you have to find what is the amount that is vaporized. So the total mass of nitrogen that is vaporized is, I'm going to label that M extra, which is equal to the heat energy that we just solved divided by the nitrogen heat of transformation. Plug that in. The extra amount of gas that is transformed, the extra amount of liquid that's transformed into a gas is 0.1 kilograms. And then you just get the moles of that, which is 3.57. And then the next step is to find the amount of liquid nitrogen, the volume of liquid nitrogen that was vaporized. And that could be given with the M extra that we figured out, divided by the density of liquid nitrogen. So the total volume of the liquid nitrogen that was transformed into a gas is 1.23 times 10 to negative 4 meters cubed. And now we have to calculate the original moles of the nitrogen gas. So pretty much the amount of gas we had before we dropped in the iron and sealed it off. So this is what we had before. So you could use the ideal gas law. So you get N original is equal to the original pressure times the original volume divided by R and T. So if you plug all that in, you get 0.273 moles. Okay, and now we have to find the how much the total moles is. So the moles you had originally before you dropped in the iron and sealed it, and the moles you had the extra moles that were vaporized. So that we solved already. So you just add the original amount of moles and the extra amount of moles, which is 3.843 moles. So that's the total amount of moles you have. And now we have to find the total volume. So once again, it's going to be the original volume plus the extra volume that we have solved earlier. So the original volume was, remember, 2000 minus 500, 1500 milliliters. Convert that to meters cubed, you get 1500 times 10 to the negative 6. And then the volume extra that we solved was 1.23 times 10 to negative 4 meters cubed. So your total is going to be, your total volume is going to be 1.623 times 10 to negative 3 meters cubed. So finally, the final pressure is going to be given by the N, the moles total, R times the temperature divided by the total volume. So when you plug that in, you get 1.515 times 10 to to the 6 pascals. And then you convert that to atmosphere, you get 15 atmosphere. So that is the total pressure of the gas after you drop in the iron and seal it for a few seconds. So that is the final pressure. So the pressure increased.